Good evening, all. Myself, Dr. Mahesha Vai, Associate Professor, Department of Artificial Intelligence, Maharaja Institute of Technology, Mysore. First, I would like to welcome our respected founder, president, and principal, Maharaja Institute of Technology, Dr. Murali S. And also, I welcome Dr. Hemant SR, Head of the Department, Artificial Intelligence, Maharaja Institute of Technology. Now, I would like to welcome our resource persons. First, Dr. Mohammed Ali. He is a professor, Saudi Islamic University, Saudi Arabia. And we have Surya Kopula, lead detection engineer, cyber security, State Farm Insurance, Atlanta, USA. We have Srirang Kulkarni, Director of Examinations, Manipal Institute of Technology, Bangalore. We have Dr. Mahesha Hudur, Professor, Government First Grade College, Ukeri. We have Shrikant Jare, I&F Decision Science Practitioner, Accenture Artificial Intelligence. Next, we have Gajendra Deshpande, Managing Director, Theta Dynamics Private Limited. Next, we have Bhushan Kapkar, Senior Gen AI Architect, Optum. Next, we have Pawan Kashyap, Specialist Scientist, FinServ. Next, we have Kalyan Prasad. He's a AI and Data Science Leader Advisor at Kaggle. So these are the our resource person for this ATAL FDP. Now I would like to request our principal sir to address the gathering.
Good evening to all of you. My voice is audible?
Yes, sir.
Okay. Good evening to all of you. It is my privilege to welcome all of you to this program, FDP program, ATAL FDP program. Participants from all over India. I'm seeing a lot of people are joining still, and a lot of people have responded to our queries from our request to be there in this particular program. So I should congratulate first of all Department of AI for conducting this particular program for the benefit of all faculty members across India. These kind of programs, when we were young faculty members, we used to do a lot physically. Now the mode has been changed. People have accepted online mechanism to learn these kind of things. So this will help people to be there at their own place and understand the concept instead of traveling. That takes more time. However, there are a lot of advantages of attending through online or also through offline. But online is advantageous because you can be there at your place and listen to the lectures. Of course, offline will connect people more physically, so therefore you can talk to each other, understand each other, discuss each other, and research can be discussed across table. So this is with the physical. However, we should thank ATAL FDP for assigning this particular FDP program to AI at MIT, headed by Dr. Hemant, Victor, and other faculty members of AI department at MIT Mysore. So I've been asked to speak on artificial intelligence and its importance. Since I am a person in computer vision, I've seen the list of activities which are there. Varieties of artificial intelligence topics have been included, and people coming, of course, coming means online, are there from different parts of globe. They are giving lectures, they are highlighting, they are addressing. So more than anything, if you'll be get connected to these kind of people, my suggestion to Dr. Hemant is actually maybe if you can get one session, so try to ask people to open up their videos and ask them to discuss amongst the participants itself, actually you may find numerous amount of experts. They would be able to give a lot of suggestions, lot of inputs to many other people. So therefore, if there is a scope in your sessions, starting from today, it goes till another 6 days. So you can try to include this particular part of making the participants themselves to discuss, understand each other, discuss, explain a typical kind of AI problems, which of course may enhance us the knowledge with other participants. And also we can give scope for some of the young researchers who are doing, they're just trying to join this program, try to understand. So they will also be highlighted, they'll be getting benefit out of this. So I've been asked to speak about this artificial intelligence for 15 minutes. So rather be taking into a specific topic, so I am now taking you, because I am working in computer vision, a specific area called computer vision. We have taken some patents on computer vision. All my research scholars are working on computer vision. So therefore, I am trying to focus more towards how artificial intelligence can be used in computer vision, rather than talking on enormous amount of generic topics. So I would like to restrict myself only to computer vision, where I am specifically working. However, I'm seeing in most of the engineering colleges and degree colleges and all, artificial intelligence has been involved, been part of the syllabus. Every student, every faculty member, every engineer, whoever is there, actually even household persons are now talking what is this artificial intelligence and all. But this is not something new when you really compare it to human system. Human system, you can consider this is the 100% benchmark for any of the artificial intelligence reference. In future, this artificial intelligence may be get bored with the kind of knowledge which is giving, as you know that actually since so many years, people are now getting fed up with the Google, people are getting fed up with the YouTube, people are getting fed up with the Facebook, because it blows up a similar kind of data. So rather you need to look at something new, something innovative. But if you really look at the kind of AI, which is now, it is not AI, it is an intelligence which is being incorporated in the brain. So that brain itself is the benchmark for all our artificial intelligence, that too specifically with the computer vision. So I would like to present with my presentation with slides. Any one of you can just tell me whether it is being seen or not. You are able to see?
Yes, sir.
Okay, so I would like to focus more on computer vision, where I am specifically working on computer vision. So that's why I'll focus my presentation only with this. Computer vision is just like the vision which is there for human system. When you get up in the morning, 6 o'clock, till you go to bed, your eyes are open. Eyes are basically a camera. It captures images. It captures videos. Of course, you may feel that actually it captures videos and get associated with the time, but basically it captures images. It is ultimately whatever computer processing or whatever you convert this into image processing. Ultimately, your eyes basically captures 25 frames per second, and this is being processed in the brain. Only camera is there as a eyes are there as a camera, and it captures, and it goes to the brain. You can see now. You can look at my office. There is one doll which is kept there. There are some idols kept at the back side. My hands are kept up. You are able to see some background. Most of the people who are seeing this video, you are able to assess the objects which are there in my room. Though you are sitting at different places, someone may be sitting in Andhra Pradesh, someone may be sitting in Delhi. The camera which is there in my computer captures the scene and shown to you through this Zoom meeting. You're able to see this. Many of you can assess what is there in my room. At least you are able to see it. And you try to compare this with our human, what we do it without this presence of this computer. When I look at around, I'm able to see a lot of objects. Lot of objects have been seen. I'm seeing AC, I'm seeing some posters, I'm seeing some dolls, some items, some kind of things. Everything are all captured by my eyes, and I'm processing it. Processing it means what? I can do anything. I can get connected from where I just purchased this clock, from where these parts have been purchased. What is the price that I have given? On which day? On approximately maybe 2 years before I purchased this. With whom I went to buy this, part. You say anything, you see any object through your eyes, you're able to assess many related things associated to it. Any human system does 100% perfect in a computer, in a vision-based activity. It is a benchmark. I already told you, human system is the benchmark. And the kind of intelligence which is there, unbelievable. Unbelievable in the sense, just now I gave a lot of examples. Something like that, this part I'm able to see. Of course, you are not able to see. So I'm able to see this clock. This clock given by somebody else. When you see this object through my eyes, I should be able to assess many things for this clock related to this clock. Who has given this clock? When did I change the cell? Right? When did I clean this actually? Whether this clock is really matching with the other clock which is there in my room. Many things I'm trying to correlate when I look at this clock. This is what the intelligence I'm trying to take it out from my brain when I look at the object. Artificial intelligence that we are now talking, trying to imitate the similar activity of the human. As a human, I see hundreds of objects. For all these objects, I have some stories. I have some connections. I can say something, at least some tags, some lines on this. These can be made out through my intelligence, which I've acquired it. Similarly, if you can imitate the similar activity with the computer based, then it becomes computer vision. But computer vision is not just sufficient. Just capture the image. It's not sufficient. Like how I'm doing it, I'm capturing through my eyes and I'm processing it in my brain. I require some processor, some intelligence, some database, connectivity with the time. And more than anything, what you are seeing is a two-dimensional, basically. But your eyes basically captures 3D because of two eyes and process it in the form of 3D. So therefore, there is one major lagging when you do with a computer-based image processing or computer-based computer vision and trying to incorporate intelligence to this machine. That is really taking up one, that has become a handicap because one dimension itself is not missing. It has got only X and Y. You are supposed to regenerate a third dimension for this and try to add time dimension for this. Then, of course, time dimension can be easily be added, not a problem. But however, adding up one more dimension, Z dimension, is really a complicated process. So therefore, intelligence, when you are trying to do imitation like a human system, first thing that you are supposed to do is for all these cameras, which basically gives you two-dimensional, you're supposed to add one more dimension to it, Z dimension. If not available, you are supposed to synthesize that. You are supposed to artificially generate. So therefore, artificial intelligence starts at the first level in computer vision by adding up one more dimension itself actually. Now you are able to see this. There is a gap. There is a gap at least 2.5 feet from my face to this. But when you are seeing all those things, you are not able to see the gap between my head to the back side of this. Because of when I put my hand like this, actually, you're able to assess the third dimension. It is only the intelligence it is working on your brain. Can my artificial intelligence can do these kind of imitating and synthesizing the third dimension, which is basically missing. So therefore, intelligence starts in computer vision with this kind of activity. So therefore, there is a tight relationship between intelligence, artificial intelligence that you are trying to do with your algorithms, whatever, with the images that you are capturing through the camera. then it becomes a whole model of computer vision, which is basically imitating the human system. But whatever said and done, as and today, with whatever the intelligence machine may be having, but it cannot do the processing like a human system. It cannot do, because human system can combine many multimedias at a time. It can connect audio with the video directly. That is not possible with even whatever the kind of existing system which is available. So therefore, we have a reference benchmark. So I'm trying to at least make some 50%, 25%. All people, all participants on this FDP should start appreciating, even if you make 10% of the human system, that itself is the biggest, ladder that you would have just, climbed in artificial intelligence with respect to computer vision. I'm not telling about AI with other areas. In other areas, they have outperformed. They are already ahead of human system. Whereas, especially with the computer vision, even 10% is not being reached. It is only because the kind of intelligence we use it on everyday working, even to eat something in my plate. Actually, I use a lot of image processing, computer vision kind of thing, to synthesize, to do that. A lot of swimming has to be done. So therefore, basically, when you look at computer vision, it has got three components. One is actually image recognition, which is there. You're able to see. Can anybody tell me? Victor, you're there? You're able to see slides? Victor? You're there?
Sir, yes, it is visible, sir.
Oh, somebody
Yes,
should
sir.
at least prompt me, so therefore I can.
Yes. Okay, sir.
Okay.
So this is Dr. Mahesh. Actually, I'm the coordinator. It is visible, sir.
Okay.
Yes,
Somebody
sir.
should just respond
Yes.
to me.
Okay, thank you, sir.
Sharing is turned on. Okay, share request now. My sharing is not done now. Is it sharing is done?
Now I'll do, sir. I'll make you as host now.
Okay, please.
Okay, sir.
Please tell me now it's visible.
Yes,
Share
sir.
my.
Yes, sir. It is visible
Okay,
now.
thank you very much. So image recognition. These are the three steps that basically we do it. Actually, image processing, reconstructions, and reorganizations. So these are some of the things that we do it on a computer vision. There are 4 steps basically. Of course, there is one session on computer vision, artificial intelligence in computer vision. So that gentleman would be giving more details. So since it's a beginning session, you'll be understanding, you'll be appreciating this a little more. Data gathering is one of the things that you are supposed to do. How exactly we have gathered the data as a human system, right? Like we have artificial intelligence which collects huge amount of information. Now I want some PPT to be made today by using AI technique, by using ChatGPT or Gemini, whatever it is. It would have collected huge amount of information before it gives something to me. In a very similar way, human system, as soon as you born, first 3 months there will be no vision. For next 4, at least for 1 year, it is all something amazing that you'll be seeing it, amazing kind of images that you'll be seeing it, and trying to record it. Lot of images are being captured every day, and it is being recorded, stored. Some of are deleted, some are forgotten. All those things are happening in your brain every day. When you get up in the morning at 6 o'clock, for every second you're capturing 25 frames per second in your cameras, and you're trying to store, and your brain is stored. Can I recall what has happened 15 days before at 4 o'clock? No, but capturing was done. Processing has been done at that moment, and later it has been discarded. So therefore, there is a huge amount of processing which is happening. That itself is a kind of intelligence. Whether you want it or you don't want, all these things will be kept in your brain as a memory. So therefore, first thing is actually data gathering. We do 100% efficient, absolutely no other reference. If artificial intelligence does anything 100%, it can be compared with the human system. That's it. Not nothing beyond that. Beyond that. So second is actually some sort of pre-processing. Pre-processing is just like, see, each time you are watching this, you did not process. There is a doll which is kept there actually in the corner. Each time you did not see, you looked at my face, looked at my hands, you did not really capture it. That's the kind of pre-processing your eyes does actually, not really capturing. When a student is sitting in the class, is seeing teacher, there is a fan which is visible all the time, but he is not focusing on the fan. So that is a pre-processing. I am trying to eliminate certain areas in the images. Then is actually what sort of model I am supposed to select when I make this computer vision. It means first of all I am supposed to collect a lot of information, then process it, pre-process it, and I have to select a specific model, maybe a memory model, artificial neural network, or maybe any other kind of AI models which are nowadays available. You can just go for it. And once you select the model which is best suitable for you, then go for model training. So you are supposed to do the training for this machine to analyze, to process, kind of thing actually. Now, just to give you an example, actually, in our earlier days, we took a patent on depth measurement. We did thousands of images, thousands of videos being given to system, and we measure the speed at which a person is moving. A person at what speed is moving. So we collected a lot of information, pre-processed it. We have selected neural network, and we did the training on those many kind of data, and we found out the depth means depth, basically finding the z. If you know the z, then easily distance can be measured, and easily the speed at which the person is moving can be measured. So we did it, and we got the patent for that. So it means model training. You are supposed to do the model training in a very similar way. Even in a computer vision, actually, you can recall your LKG class where your teacher would have just said yeah, so many number of times on your slates or your books like that. Then the B, it is very true that actually all of us, we can recall our earlier days when we learned B, we have forgotten A. So then A and B both are to be given together. Then of course the C, when C has been explained easy, right, like the C like this, then we have forgotten B. A, B, C to be given. So therefore you are supposed to do training with a lot of data sets. So what are the kind of activities that you do to make computer vision? Of course, I'm not really giving from the perspective of intelligence, because all these things ultimately leads to artificial intelligence, because these are some of the algorithms that you are developing in the computer vision. They are artificial in nature. What is for the system, human system, that is a natural system. So therefore, image recognition, image classification, object detection, image segmentation, object tracking the objects. You would have seen nowadays AI cameras are there, actually it tracks the person like that. Scene understanding. So you can see from this background scene what are there, which are there, kind of thing. Object, identification, scene understanding. You can really make out that actually Murali, now he's sitting in the office itself. It is not at the home. So therefore, this is scene understanding. So facial recognition. So if sometimes after some time, if I am coming again on the screen through the Zoom meeting as a participant, then somebody should prompt saying that actually Murali has come. But on that day, I may be wearing a different shirt, but I should be identified. So this is what is called as a face recognition. Then pose estimation, in what pose actually I am sitting. So there are a lot of things that I am doing it through the machines. Optical character recognition, this itself is a separate area, but that is also part of the computer vision. Image generation, yes, now AI is doing a lot of image generation, that is doing based on some data. And visual inspection. Inspection means identifying certain things which normally you are not able to see it through the eyes. So maybe when you take the images or the videos of the forest, there are hundreds of trees. For my eyes, all are looking similar. But when you take it out, actually, this plant color is something altogether different. This plant color is altogether different. This is possible only with the machines. Only the reason is computer can sense huge amount of colors, whereas human being, I can recognize only some 200, 300 colors. So that is why I can just go for, visual inspection by means of this, identifying certain things which I am not able to assess this. So these are some of the computer tasks. They're all leading to intelligence, artificial intelligence. You are trying to give some sort of intelligence to the machines. Hundreds of applications are available. I'm not able to explain because I'm running out of time. Like agriculture, I've written some specific kind of applications like agriculture. You can just use it because now India is coming out with a lot of innovative mechanisms in AI. Why don't you apply this for agriculture? Agriculture where you can capture the farms, crops, etc., and all, analyze these images and identify the plant health. Now, like how I'm doing it through my eyes. You go to my village. I'm from village. You go to village. My co-farmer identifies what is happening to this paddy. It is only by looking at his eyes. Can you just do by very similar kind by using the machine? Then it becomes artificial intelligence, right? Then autonomous vehicles. India has not produced yet. Actually, other countries are there. Then we have a healthcare where in which hundreds of things. Yesterday, I've seen, in Noida, there is an hospital, the entire hospital, absolutely no doctor, no nurses, nothing. Entire hospital. It is a big hospital I've seen yesterday in the newspaper. So that's a kind of healthcare, mechanism where with the receptionist, where in which you are going there in front of the machine and telling you are so and so, I want this consultancy. Then the doctor will be sitting there. You go there, some voice will come, say that actually you put your cuff like this and press like this, and that will tell you the BP. So this is how actually the modern kind of thinking which is there in healthcare. Of course, in manufacturing, I am now telling all those things from the perspective of computer vision, not as a generic artificial intelligence, only from the perspective of computer vision. Similarly, in the manufacturing, of course, in the retail and commerce, of course, in the robotics path planning actually. Now I am able to move to the left side or to the right side, depending on the space that is available here or here. We will identify the space. The space to move for a robot is identified by through the computer vision. So therefore, computer vision can have a lot of intelligence being imbibed, like how we do it actually. When my door is opened, actually I don't go. So therefore, I should be able to identify the path which is there to my door. So my eyes does without any difficulty. In a similar way, the machine should be able to do that kind of identifying the free space automatically when it captures the thing. Then I thought actually this is one of the things that somebody can start exploring it on a space exploration. There are a lot of hazardous items which are there in the space. A lot of debris are coming there. So can somebody identify all those things through the another kind of satellites and identify the active live objects and unlive objects? So therefore, the debris can be cleaned in future. Actually, maybe some 50, 30 years now, you will have huge amount of debris in the space. Some intelligence can it be used to identify kind of this. So I'm trying to conclude it with some of the tools that you can use it as a readers, as a users of computer vision. Like we have, these are some of the free tools which are available, like Keras, OpenCV, Ski Images. This is called Ski Images, right? Then TensorFlow, Torch Vision. OpenCV is very popular. I think the majority of you would have used it. Apart from this, I am listing some more, computer vision tools that you can use it. Anyway, I'm sharing these slides with Dr. Hemant so that we can also look at, you can remember these things. I've listed out certain, specific features of tools which you can use it, like Keras, how it is used, OpenCV, etc. and all. Skillet is basically, TensorFlow, all of you may be familiar, it is developed by Google, and Torch Vision. So these are some of the tools which are available for computer vision. So with my time given, maybe for 15-20 minutes, I thought of saying that computer vision, don't try to look at as a kind of a new artificial intelligence, like you have new generation kind of software that you're coming out. You are trying to develop a software which is trying to give life for your camera itself, that itself is intelligence that you're trying to add up. That itself will become a new kind of development in the research. So congratulations to all of you for making this kind of event possible, specifically headed by Dr. Hemant and his team, taking a lot of difficulties in arranging these kind of programs. I know that difficult time from 6 to 9 o'clock you'll be at your house. In spite of that, you have taken time to attend these kind of programs. So congratulations to all of you. I hope you will be seeing and you'll be getting a lot of benefit out of this 6-day program. I've seen the schedule. A lot of good people are coming and explaining the research of their study, and it will be beneficial to you. As I suggested in the beginning, Dr. Hemant, if you are listening, please make, if there is a possibility of making some of the participants giving their ideas, at least maybe you can give them from 2 to 3 minutes, then it will be more suitable and it will be more apt. So thank you very much for all of you, and enjoy the days. Thank you.
Thank you so much, sir. Thank you so much.
Dr. Mahesh, you can
Yes.
go ahead with your other part of the program.
Yes, sir. Yes, sir. I will do this, sir. Thank you, sir. Thank you.
Okay, so I'm online actually. I'll be listening for some more time.
Okay, sir. Okay. Thank you, sir. Thank you. Okay. So now you can join. Now you can share your screen, sir.
No, yeah, my audio is visible. Yeah, audible.
Yes, sir. It's audible.
Yeah. Share, requesting share screen.
Sir, your host, you can share your screen, sir.
So is it visible? I have shared the screen.
No, sir, not yet visible. Uh,
But now,
Sir, it is showing started screen sharing. I think you have to try once again. Now it is visible, sir.
Visible.
Yes, sir, it is visible now.
So my face is not visible. I shall the camera also. So the camera is on. Am I visible there?
Sir, video is not visible, but slides are appearing, sir. Slides are visible
Yeah.
now.
Camera is coming up. So I'm
Sir, you can start giving presentation.
go to camera.
Okay.
Camera is on actually.
Okay. Okay, sir. Now it is visible. Camera is okay.
Camera is okay.
Yes, sir. Yes, sir. Yes, sir.
Where I am just looking at this. Anyway, good evening, audience. If somebody can, I think all are muted.
Yes, sir.
I
All are
don't get
muted. Yes.
only Dr. Mahesh will respond. Am I audible to you all?
Yes, sir. It is audible.
And I think I'm
Thumbs ups are
visible to you
coming.
all. Yeah, appreciate and kudos to all of you for participating in this wonderful topic on artificial intelligence. And appreciate you are taking time out in the evening to learn something and upgrade yourself. And most of you may be practicing, maybe research students, and maybe teaching artificial intelligence in your own way and in your own profession. I'm glad to interact with you in this evening. And at the outset, I would like to thank the coordinators of this faculty development program. I understand what it takes to arrange such workshops. And I highly appreciate the team, Maharaja Institute of Technology, led by Dr. Murali and Dr. Mahesh, for having taken pain and attracted the grant as well to enhance the culture of learning. Thank you very much and for giving me this opportunity.
Thank you, sir. Welcome, sir.
Yeah, I am just to introduce briefly about me. I'm sitting right now in Riyadh city at my home in Saudi Arabia. I'm working as a professor in the Department of Information Technology in Al Imam Muhammad bin Saud Islamic University, Riyadh. It is one of the government universities in Riyadh. And stop a companion. Okay. Well, somebody requested me to stop a companion. Okay, I've done it. Well, I was telling about myself, and I actually took my PhD, earned my PhD from NIT Warangal, then worked in some engineering colleges in India. And since 10 years, I am in Saudi Arabia, teaching different courses and other things. And recently, I have taken a consultancy task as a AI director in one of the companies. We have founded a company called Mesaki.in, and I am in charge of the development operations in Saudi Arabia. That is also a parallel job I am doing as a consultant director of AI. That is about me. Today, I'm trying to give you a different perspective and I want to take you on a different journey. Conventionally, you will learn lots of technical stuff about the recent LLMs, chat GPTs, and fancy terms and fancy applications and ambitious research that is happening and all. But today evening, I want to take you on a different journey and trying to dig deep into the material aspect of intelligence. And from there onwards, I want to explore towards the evolution of AI. The task that I am given today is just to kickstart the workshop. In rather, the topic is a topic of kickstarting the workshop, and it is a beginning topic called Introduction to Artificial Intelligence and its Evolution. I hope the slides are visible. Still, I am showing you the first slide, and I will. Mahesh, is it visible? First slide. First slide is visible.
Yes, sir. Visible. Visible, sir.
Visible. Okay. Is full screen visible or okay? I will move to the second slide. Second slide, what I have done is I have just designed an application. Is it audible to you?
Yes, sir. Audible, sir.
आज हम मस्नूई ज़हानत और उसकी मुताबिकत के बारे में बात करेंगे। ये न सिर्फ जदीद टेक्नोलॉजी बल्कि हमारी जिंदगियों को भी तब्दील कर रहा है।
Again, I would like to replay this. I hope you heard the
मुताबिकत के बारे में बात करें। ये न सिर्फ जदीद टेक्नोलॉजी बल्कि हमारी जिंदगियों को भी तब्दील कर रहा है।
Mahesh, did you hear this audio?
Yes, sir. Audio is yes, sir. I'm listening. Sir, make it a slideshow, sir. Then it will be enlarged.
Okay.
Okay. Yes, sir. Now it's perfect, sir.
Perfect. Okay.
The video was no, audible, sir. The previous video.
It was audible?
Yes, sir. Yes, sir. The video,
Yeah.
what
The
you played.
purpose of showing that video was how quickly this person is not existing on the earth. This person is not the real person. But I have used that person to present some content. So in future, you will see that the role of a physical teacher or a human teacher may not be there in the universities. I would like to see such individuals coming and explaining the stuff that I'm doing regularly in my institute. And that is a risk that you are facing as a teachers. Okay. What I'm coining it as a AI Guru University. In future, you will see there will be universities with AI gurus in the universities. And they will take the content of the teaching material and they will make nice humanoid presentations. And this is the risk that you are going to face in the coming 5 to 10 years. And my colleagues, be ready for such challenges and try to drift away from what you are currently doing or augment yourself with other eligible stuff that with which you can survive, right? And this is a very decent presentation which I created within 30 minutes, 30 seconds rather, 1 minute. Okay, just for the sake of presentation sake today. Okay, this guy is presenting some talk, and these kinds of application you will see, and you are seeing already in other domains. So AI generated images and videos, they are narrating the stuff. And this is quite possible. It is not a dream or fancy or any quixotic feeling, but it is a reality these days. How this is all happening is the question. How it all started and what were the seeds to start such kind of activity. And it is moving in an exponential way. The growth is very exponential. Okay. So my attention to, I would like to draw your attention to the very fundamental things of intelligence, and let us start discussing or elaborating on that. Okay. So when I coined my talk and generated the word map of it, and the word map was showing all these terms. I hope you can see that. Repeatedly, I want some acknowledgement, Mahesh, because all other audiences are audience is muted.
Yes, sir. We are able to see, sir. Yes, sir.
Just yes or no, something like that. Yeah. What I'm telling is when I generated my content for this speech or this talk, and I saw the word map, The word map is showing these words: AI, intelligence, knowledge, constraints, materials, blah blah things and all. This is the stuff around which I'm going to talk today. Okay, so in my understanding, or in my viewpoint for today, intelligence is not merely a software construct, but a physical, biological, and civilizational phenomenon that unfolds across time. The AI is not taking place today. AI has been taking place since human civilizations have existed in one or the other form. If you go into the Indus civilization, if you go into Mesopotamian civilization, if you go to the Egyptian civilizations, you will find glimpses of AI being seeded in those civilizations. Therefore, intelligence is not merely a software construct that we are talking today. It is physical also, because it exists in the material. It is existing in the biological. My next question to you will be whether only living beings do have the intelligence, or even the non-living things also have intelligence. I throw open that question for your thinking. Let us try to understand and deliberate a little bit on this question also. So, at its most fundamental level, intelligence emerges from matter organized under constraints. What are the constraints? Constraints of energy, information, what information you are getting, and what is the feedback coming to those constraints. From atomic lattices to neural assemblies, and from social institutions to computational networks, intelligence presents progressive alignment of matter toward adaptive purpose. This is a very strong sentence and a very out of the box sentence I'm making. I draw the attention of the listeners on these things. Intelligence represents progressive alignment of the matter. Basically, while creating intelligence, what we are trying to do is we are trying to align the matter in a particular way. When I'm talking to you, you are listening, and the energy is getting into your body, and the matter in your brain is getting aligned in a particular way, so that we reach an objective of learning AI today evening. That basically, at the microstructure, if you see, there is an alignment of the matter going on whenever we interact. And this alignment of matter is the basic thing I want to catch in defining the intelligence. Whether you are creating natural intelligence or artificial intelligence, what we are trying to do is we are trying to adjust the microstructure in the brain. That is why a student learning from the LKG to higher education, his matter keeps on getting aligned and he becomes intelligent, and he solves very bigger problems that he could not have solved in his earlier age. So I'm looking intelligence from the perspective of the matter alignment. That is the drastic different view I want to take in introducing this topic. Okay. Yeah. After having spoken about those things, this is my introduction that I'm Associate Professor, Department of IT in CU Riyadh, which I have already told. And this is my related visiting card, which I have pasted here. Okay. Let us move on. And let us question ourselves, what is intelligence? For a general man or general novice person, intelligence is basically adaptation. If we can adapt to the circumstances, we call that we are very intelligent. And in nature, we see this intelligence often. For example, I have shown some images. This man, this cartoon is coming under the rain, and since it is raining, he opens the umbrella. And since he is intelligent, he is able to open the umbrella and protect himself from the rain. Okay, so the objective of this intelligence is to survive. Always the intelligence tends to get into one final motto, that is survival. So that there should be some objective for creating the intelligence. And if it is a man, he is intelligent. Do plants have intelligence? My answer would be yes. Plants also have intelligence. You see, this plant is trying to get energy from the sun. It is orienting itself towards the sun. So that means it also has got intelligence. Do plants only have intelligence? No, even the smallest bird on earth also has got intelligence. And no wonder it builds the homes and shelters, very scientifically constructed shelters and very complicated shelters it builds. And this also has got intelligence. So what intelligence is, it is trying to adapt. So intelligence is equal to adaptation is the basic definition what I can take it as today. I have given many examples on the screenshot here. Even ants have got intelligence. They move in a particular fashion. And the honeybees have got intelligence. And birds also have got intelligence in flocking in the sky. And rabbit, when it sees some risk to its life, it escapes into a groove or a hole. Okay. So how it is happening? Because they are trying to adapt to a particular circumstance and try to survive. And this is happening with every object in this universe. Okay. So that is why intelligence is basically adaptation. I hope all the audience will agree. And no wonder, based upon these observations, there is a separate stream of learning has begun in AI, that is swarm intelligence and intelligence from natural observations and colony optimizations and all those things. In the detailed study, particularly AI student might be doing. So we all accept that intelligence is equal to adaptation. We should not have any argument to accept this definition. Let us get into little deeper into this. Manifestation of intelligence you will see in real life. Living animals manifest because the tiger is a manifestation of an intelligence. The creator or nature, whatever you call, the nature has intelligently created this, and it is the example of a product out of that intelligence. The tiger, tree, ants, birds, and whatnot, giraffe, all the creatures, they are the outcome of the intelligence that is available in the universe. I would see like that. What is the purpose of creating that intelligence? Is to make it survive to the circumstances. Similarly, non-living manifestation. Human beings have created some objects, bicycle, notepads, scissor, microscopes, robots, satellites, cars. These are all the manifestations of intelligence. I hope the audience will agree here. Now the question is, where from any intelligence come? What is the origin of intelligence? Living things have intelligence. What is the limit? Do non-living things really have intelligence? This evening we should keep thinking on this, whether non-living things also have got intelligence. How different is the intelligence in non-living things? Is it same as the living things intelligence? Why is intelligence in non-living things difficult? Why they cannot think like what the living beings think? How to create intelligence in non-living things? These are some very crazy questions that arise when we start thinking on this in this evening. These are very fundamentally and open-ended questions, and you can you can keep thinking and keep pondering. Probably in a useful answer you may get. Let us try to ponder over these questions. First is, I question myself, where from this intelligence come? So my catch was, the origin of all the intelligence is this. I hope you are able to see the slide.
Yes, sir. Yes, sir.
Yeah. The origin of all this intelligence is this only. The universe is the origin of the intelligence. Because the input to this intelligence comes from this origin, that is, energy comes from this. For us living on Earth, the main source of energy may be coming from sun in a photon form. But other stars and galaxies are also contributing their own bit of energy to us. So origin of intelligence comes from us, and we manifest all that intelligence. Again, it goes back to the same universe. The intelligence comes and intelligence gets contributed to the universe. So this I call it as a production cycle of intelligence. Let us see what I mean by production cycle. Give a careful attention to this. This is my mind diagram. This is my viewpoint of production cycle of intelligence. So what I'm seeing in the left side is intelligence is produced by energy transformations at the micro and nano structures of the matter. How intelligence is produced? Intelligence is produced by energy transformations taking place at the microstructure and nanostructure of the material. The material could be anything. It may be a biological cell. It could be a brain cell. It may be a stone. It may be a rock. It may be a magnet, or it may be anything. What energy does is energy makes the microstructure transform in a particular way, and the intelligence gets created there. That is what I'm seeing in the left side. So matter microstructure transformations will take place due to the availability of energy. And if that energy is not available, and don't expect that microstructure to reorganize itself. But if it is reorganizing in a meaningful way, in a useful way, then it gets manifested and it becomes acceptable. Otherwise, everything is getting reorganized and organized by the hit of the energy in this universe. But we don't appreciate all that phenomenon as intelligence because that is not useful and that is not contributing anything substantial. On the right side, I have shown when intelligence and energy are combined, what happens? When intelligence and energy are combined, what happens is the production of the matter. I pause here. I will allow the audience to think whether I'm right in saying so. Mahesh, it would have been very interesting had you made it interactive, but for the reasons of bandwidth and all, you probably have muted other audience.
No, sir. It is because of yeah, they may you may get disturbance. We don't know where
Yeah,
exactly
it's okay.
those people
It's
are.
okay because it is becoming monologue.
Yes, sir.
But however, I hope I am able to reach to the audience.
Yes, sir. Yes, sir. Absolutely, sir.
Okay.
It is going very fine, sir.
Yeah.
Yeah.
Yeah, I am trying to think over the right side of the diagram here. Intelligence, when combined with energy, results in matter microstructure transformations. I hope you agree. Sometimes, when I am sleeping, when I am walking, I think how the Wright brothers have invented aeroplane. Aeroplane was not there before that 100 years, but they invented it. Today, ChatGPT has come. 10 years down the line, ChatGPT was not there. 20 years down the line, there were something was not there, mobiles were not there. How these things are coming and getting realized? Try to give a thought about them, you will get the answer. So my right side diagram will explain how the matter or microstructure transformations are taking place, because intelligence, we keep thinking. When we start thinking, the matter in our brain starts getting aligned in a particular way. Millions and billions of neurons will start getting aligned. And where for that alignment, we require energy. Of course, that energy as a biological species, we take from food, and naturally it comes from energy, it comes from sun and other things. There is some energy input. And when we start pondering about a particular problem of any thinking, because they say creativity is random human activity which comes after constant thinking. Okay, if you constantly think over a certain problem and that problem aligns the matter in your brain in a particular way, and outcome of that, you will see that the material gets generated in the real world. Okay, I'm making a very strong and revolutionary sentence, I hope, because I always think why mobile is coming today, because somebody thought earlier about mobiles. Tens and thousands of people started working, university professors, students, in the form of their projects, learning activity, and all those things. They started thinking and working. In the process, what happened is the matter in the human brain got aligned in a particular way to produce that microstructure or the product. So this product will be visible in the real time. So this is a cycle actually. The energy has come from the universe. I thought and my matter got aligned in a particular way. Then I produced the object. The object is a reality today. Today, ChatGPT is a reality. Google was a reality. Then aeroplane is a reality. Mobile is a reality because that intelligent thinking was going on, and there was a supply of energy parallel to that, both combined, and matter is produced. And this is going to be true for a time immemorial. Only thing is, you should keep on thinking and working. Today, we are attending in a workshop. This is a process of intelligence input that we are giving collectively to ourselves. I myself prepared a presentation, and you are listening to that. Hundreds, 240 participants, I find. I don't know, after YouTube and other things, other few will start listening to that. So this is the process of intelligence and reorientation of matter in our brain. And as long as we are alive, we keep absorbing the energy. And who knows, one of us will be able to produce some object in reality in the world. And this continuously happens. And civilization evidence for that. Our scientific inventions are evidence for that. And contributions of our scientists are evidence for that. And this is what I'm calling it as a production cycle of intelligence. And probably this is the takeaway from my talk today. I have made some serious thinking on construing this idea and forming this slide, actually. I hope you appreciate. And moving on, my topic is, I'm coming to the introduction and history and evolution of AI step by step. But this is where I wanted to pitch in and kindle your thoughts. Hope you start thinking and exploring this matter. And make your children, we send them school, we make them children learn. Why? Because we want the intelligence gathering. We are basically allowing them to reorient their microstructure in the brain. They are not going to school, actually. They are going to every day they are going and realign their matter in the brain. In that perspective, I see it. Fine. I will move on. For paucity of time, I will just be a little fast. Well, production cycle of intelligence, I have just embedded inside the universe, the creation of intelligence, then use of that intelligence, and it spirals and grows regularly like that. And the universe of intelligence keeps expanding. And of course, the physical universe is also, I am told, it is expanding. Okay, it is not a universe kind of thing now these days. It is a multiverse. Multiverse is expanding, and spiraling intelligence is contributing to that. Well, my initial questions still stand same. Whether availability of intelligence, is it available in non-living things, or is it available in only living things? When I think over this point, what comes to my mind is, what is this magnetic induction is doing? It is lighting the bulb. Why it is lighting? In magnetostriction, you will see, as long as the poles are aligned in a particular way, it will not get attraction power. It will not attract the other things. So the matter has to be aligned in a particular way to get that power of attraction. So I see that the both answers are yes and no in non-living things. In one way, if you think non-living things also have got intelligence. The other way, in the perspective of the living things and their intelligence, if you compare, then I can say that non-living things don't have intelligence. But if I stick to the definition of intelligence as the matter alignment, then I would promisingly say that even the non-living things also have got intelligence. I leave it to the audience to think over and debate and criticize this viewpoint on intelligence. Okay. In living beings, of course, we all agree that intelligence exists at innumerable places. I have taken examples of how bacterial colonies develop, pathogens will group, and how bacteria grows. Even that smallest creature, which is not visible to us, the intelligence is there. And in human cells, the intelligence is embedded in RNA and DNA structures. Okay, there is a particular alignment, and that alignment brings into the manifests in the form of our skin color, our living being, our gender, and our hair color, and blah blah things, and so on. And basically, that is the intelligence available embedded within the cell. So it is not difficult to accept that living things have got intelligence. But the non-living things, whether they have got intelligence or not, is debatable. And initial thought process I will kindle from the observations like magnetostriction and magnetic induction and various other phenomena. Fine. I am not making a random argument here. There are some references to this. This slide, if you are seeing, could intelligence is equal to matter seeking lower energy, higher order informational alignment? Yes, you can read the references here. Free energy principle by Carl Friston. If you are more interested in this argument, you can extend this argument. Free energy principles. Then intelligence is equal to degree of structured and interconnected alignment. What I'm argument is, as if you align a particular matter in a particular degree of structure and interconnected alignment, if you do it, then that creates intelligence. Okay. If you want to debate and argue and collect more material on this, then this Tononi, the paper and author of Tononi, Integrated Information Theory, will help you to make some solid conclusions on this. So order emerges when systems self-organize under energy gradients. Basically, intelligence is creating an order of the matter. If it is a randomly scattered, probably it may not be useful intelligence. But when you create an order out of that randomness or entropy, when you bring down the entropy and align it in a particular way, then that is the basic difference things and living things. Still, I have not come to the artificial intelligence. I'm coming there. I want to fire your thoughts with the definition of intelligence. Okay. If we fire together, then we will be wired together. Okay. Cells that fire together will be wired together. There is a great Hebbian statement around that. So at this stage, what I'm equating intelligence is equal to the ability of systems' internal microstructure to reorganize itself in response to external stimuli toward a purpose or improved prediction of reality. The comma and after the sentence is also important. Why the system's internal microstructure should get organized itself? Because toward a purpose. The purpose could be anything. It could be a greater purpose of computer vision. It could be a greater purpose of survival, or it could be a greater purpose of listening or anything toward a purpose or improved prediction of reality. So that is what I call it as an intelligence. So the ability of systems' internal microstructure to reorganize itself in response to external stimuli toward a purpose or improved prediction of reality. Fine. I think I'm conveying my thoughts very strongly and I'm hitting your microstructure. Fine. Well, that said, let's move on. Non-living things, I'm just trying to compare the availability of matter and other things. I'll just go through the points. Non-living matter aligns only under blind passive physical forces like gravity, magnetism, temperature, not under informational or purposive forces. Whereas in living things, living matter aligns due to informational forces. And those informational forces are inbuilt in the form of DNA contains information. That is the drastic difference we find between non-living matter and living matter. In non-living matter, atoms are fixed in static arrangements, crystals, minerals, metals, etc. And living matter forms self-scaffolding adaptive architecture that moves towards survival, reduction in entropy, and optimization. What I told is, if you are able to reduce the entropy and organize in a particular way, that means you are moving towards intelligence. That is what we call it as discipline. In a very civilized term, we call discipline. Discipline is nothing but organizing yourself in a particular way. And if you organize disciplined, then the intelligence start emanating. So matter should be disciplined. In the non-living things, self-adaptation is not found towards entropy reduction, optimization, and survival. Instead, the non-living things will decompose. Okay, so that is what we think. But whereas living matter, chemically programmable. So if you add two chemicals, it will produce the third chemical. So it is chemically programmable. So chemistry is a kind of a program for living things. So it grows, it doesn't decompose. Static structure passively changes and gated voltages and currents movements. But whereas in living matter, instead of gated voltages and currents, we call it as a fluidity enables dynamic microstructure reorganization. Neurons require continuous movement of sodium ions, potassium, and calcium ions. So when they start crossing the membranes of the neurons, the matter starts getting aligned. So when I'm thinking on a particular problem, what is chemically happening in my neuron is the sodium and potassium and calcium ions are moving across the membrane. And because of that movement, my neurons will get aligned in a particular way. If I'm meditating, remembering Lord Shiva or Lord Ganesha or something, my alignment is taking place. That is why our civilization and dharma gurus, others, they stress the importance of meditation and yoga and other things. I'm broadening my thinking actually. And when you are doing these things, you are giving a brain an opportunity to transform the sodium, calcium, and potassium like ions across the membranes, resulting which the matter alignment takes place. And that matter alignment, as I told you earlier, will lead to intelligence creation. But your thought process stops only at doing the yoga and it stops there. But if your thinking process is about inventing something, and if you are thinking of out of box thinking, if you are doing, then that alignment will take place. That membrane transfer of sodium, calcium, and potassium ions will take place in the neurons towards the creation of that object. When you are thinking, I want to create a movie, or create a robot, or create a new mobile with certain features, then the matter alignment starts. So this is the power of living animals, because fluidity is there in the uh, matter. That fluidity is not there in the non-living things. This fluidity enables dynamic microstructures to allow the matter to get transferred across the membranes, and resulting which the reorganization is possible. This is what we call it as self-organization. And where from the information is coming to this, it is coming in the inbuilt information bank, what I call it as the information bank, which is available in the form of DNA, deoxyribonucleic acid. Fine. So this is the difference between the non-living and living matter. Let's go a little faster. I have consumed little time. Non-living versus living matter. As I told you, non-living things have got fixed microstructure, and non-permeability is there. Permeability is the key word. Living matter, why it is able to create intelligence is there is a permeability in the membranes of the living matter. Okay. No controlled flow of charge or molecules in the non-living things. But whereas a controlled flow of molecules and charges is possible in the living things. And we have created perceptron, the nearest mimic for the living things. Okay. So non-living things, what they obey is decay, do not maintain order, and foundation of modern AI activity is the perceptron. Fine. Well, all this summary I'm putting in this form of table. I hope you are able to read the table if you are observing on a bigger device like laptop. But if you are able to see if you are attending the workshop in this mobile, probably you will not be able to see this writing. But property needed for intelligence. Yeah, property needed for intelligence. See, why I'm taking, there is a purpose. Why I'm taking you through the journey of material is there is a purpose. I will come to that purpose at the end. So, property needed for intelligence. So, to create intelligence, what do I require? One thing I require is self-organization. If a material is capable of self-organizing, then it is possible to create intelligence out of it. If a material is able to retain memory retention, then it is possible to create intelligence out of it. If the signal conduction is possible, then there is a possibility of intelligence creation. Local learning is possible, then it is possible to create intelligence. Metabolic repair, damage control, or repair if it is possible, then intelligence is possible there. Noise adaptation capabilities. So external disturbance, it should adapt to itself, then it is possible. And how these required properties are available in the neuron, the natural neuron. If you see the biological system, self-organization is possible because synaptogenesis takes place, plasticity. Yes, it is available there. Memory retention is possible, synapses and protein level encoding, because proteins will remember the structure, protein structure. Signal conduction is available in the neuron, long gradients via membranes. Local learning is possible, Hebbian plasticity is available. Metabolic repair, immune system, when the disease attacks, we recover. That is a metabolic repair is possible in the living beings. That is the immune system is the manifestation of that. Neural chaos, creativity. Noise adaptiveness is what? Neural chaos. Actually, the intelligence is nothing but the outcome of the neural chaos. Okay. When you start thinking too much or involved in a certain thing, no, there is a neural chaos is going on. The inverse of the brain is getting disturbed. It is under the ultimate chaotic condition. Okay. Einstein's and all scientists, if you take, no, their brain is into the neural chaos. So that is the resulting in a creativity. Unless until you are in a chaotic condition, you cannot create intelligence or you cannot be a creative individual. And we agree with that. This is all the traits available in the neuron. But on the perceptron that we have created as an element of or mimicking entity of living beings, these things, these glimpses will find there. Self-organization is possible because weights are frozen unless they are trained. And the memory, we have made it possible because store only RAM or SSD. And the signal condition is possible with mimicking the long gradients, electron flow in wires. Local learning, we have made it possible with the greatest phenomenon called back propagation, which is a revolutionary idea that has come to the human society, because of which today what we are talking about AI, back propagation. So it is the equivalent of the Hebbian plasticity that is available in the neurons of biological system. No self-repair. We are trying to achieve that in the form of self-configurable machines. The research students you might have heard about, there is some research going on, self-configurable machines. If the computer or the laptop is damaged, it should repair itself. If the mobile cell is damaged, it should repair itself. Is it possible? Today, it is a difficult possibility, but we are moving towards that. So this gives the power of self-repair. Once we achieve this self-repair, then we have made a leap change in achieving the in biological intelligence, equivalent of the biological intelligence. But right now, in the artificial objects or non-living objects, this trait is missing, or very weak, rather. I don't say missing. There are some self-configurational events that are taking place. If you see if you are working in software programming and other things, earlier if the bugs are coming, then I used to go to Stack Overflow and paste the error or bug, then get the information from that, again loop back and make the changes and get the error-free code or something like that. But today, if you paste that bug to ChatGPT or something, it will give the clear steps how to overcome this. Now imagine this intelligence is fed back, and if there is an hardware entity which is mechanically moving and adjusting the machine, then it can repair itself. So the days may not be far ahead that we get this self-repair capability for our non-living things as well. Okay, and noise is a destruction in non-living things. Noise is not a creativity. Noise is a destruction. We try to suppress the noise and try to do the ordering there. But if we can utilize noise and create something, and there are some systems which are using noise to get information or intelligence out of it. One such model is the advanced learner might have come across diffusion models. Nowadays, we are talking about diffusion models, where we are trying to do is the object which is not giving us any information or any intelligence out of it. What we do is we throw noise in it and then clean the noise. When we clean the noise, then the information comes out from that object. So it is like reading a sculpture stone. Suppose from Belur Halebeedu or something, you have got a old stone on which there are some inscriptions, but they are not very clear. They are not very clear, and I am not able to see them. Then what I do is I will throw some noise on that. What is the noise? It may be a white piece of dust. I will throw on that stone. Then I will rub all the stone, which is a black stone, over which I have thrown the noise on that. Then after cleaning that, I'll see that the noise has got stuck in the inscription grooves. And now I'm able to see the scripts very cleanly. This is one technique I use it, use the noise to give me more information about it. And this analogy I have given, think on this, and noise is being adopted for creativity. That is made possible in perceptrons these days, and we are moving towards that, and we are calling them as diffusion models and etc. The terminology is given. So whatever property we have envisioned here, we are trying to accomplish them in the non-living objects also. If we achieve 100% success, then we are near to creating the intelligence that the biological neurons have got. Our tendency is to reach to the biological intelligence. Our effort has always been to reach to the equivalent of the biological intelligence. We are moving towards that. Fine. So intelligence has this stage. Intelligence emerges when a substrate continuously organizes its state based on the incoming information to reduce prediction error or achieve. Intelligence is not a one-time event, it is a process. Okay. Evolutionary continuity of intelligence goes like this. So there is a matter, then matter becomes neuron, then we created perceptron out of neuron studies and mimicking neuron. Then from perceptron, there are various in-between phases. Then we created the deep learning. So this is the evolutionary path of continuity of intelligence. Fine. The first neuron model, I'll be fast now. This literature is always available to you in many of the texts. What I talked so far is a thought process of mine originally, and I wanted to discuss with the learned audience. Now, henceforth, whatever stuff I am giving to you, probably you will see in most of your textbooks and research areas and other things. So I can go fast here. The first neuron model, McCallum-Pitts, 1948. As I told, I remind myself, my job is to introduce the AI, talk about its history and evolution. And that is a subject title for my talk. I will not do injustice to that task. Now I will jump, giving you some historical perspective of AI and its development. So just to record the substantial contributions, the first neuron model was given by McCallum and Pitts, 1948. So you can see the slide, the biological neuron and equivalent, and most of us are popular to this. So these are nothing but inputs, and there is a summation, and there is an activation function or a barrier controlling function. Then output will come. The major difference is the neuron will always activate in only 0 or 1. It will take the input and it will fire either 0 or 1. But whereas our perceptron model will fire all the levels between 0 and 1. 0.7, 0.4, 0.5, 0.6, all the levels between 0 and 1 it fires. Whereas neuron fires only between 0 and 1. That is a major difference that we find between perceptron and the mimicking entity. The perceptron is humanity's first successful attempt to mathematically recreate the biological neuron's ability to overcome microstructure rigidity and entropy big level silicon, a method to propagate signals, applying thresholds and update synaptic strengths. We should thank ourselves, and the humanity should thank those scientists who gave the mathematical model. It is worth they are worth worshipping. Today, if you are doing any AI activity, it is because of this conceptual model of perceptron. Okay, I'm happy to show you, just to bring your attention. The graphical or the schematic model is the one which is shown in W1, W2. And the real hardware model, those who are interested to rig it on the PCB board or taking some hardware devices, for them, the perceptron looks like this, the circuit. And for a computer engineer who is using the von Neumann computing model, he may write a program in any language that he knows, and it realizes the perceptron. So I have given three equivalents of a perceptron. You can execute this program and it starts working as a neural entity. Fine. And you may be trying with these programs with your students in the lab if you are a faculty, or if you are a researcher, you might have used such kind of programming. Okay. So if you're a hardware engineer, then probably you go on rigging this. This is the one circuit for a perceptron. Then imagine if I want to create millions of neurons, what will be the circuit complexity? Okay. But thanks to the von Neumann computing architecture, any program that I write, it gives the computational power of a perceptron. We use the programming to simulate those perceptron entities. Fine. How the perceptron mimics a biology neuron. Ion flow triggers in firing in the biological neuron. Weighted inputs activation function is equivalent of that. Weight threshold controls the signal passing. Weight update rule adjusts the connectivity. Training algorithm expends computation. It is equal to energy release. Whatever training algorithm you are using, it is like a equivalent of energy release in the biological cells. Output is 0 or 1 classification. Neural firing, discrete decision. Okay. So now I will come to the artificial intelligence. Artificial intelligence is humanity's attempt to give non-living matter the power of self-organized intelligence through computational systems that learn, adapt, and act with purpose. I again read for your clarity. If you disagree, probably you will raise a questionnaire afterwards, or you can pass comment. This is the comprehensive definition and a small definition of AI. AI is humanity's attempt to give non-living matter the power of self-organized intelligence through computational systems that learn, adapt, and act with purpose. I hope that makes an impact and you fully agree with my definition of artificial intelligence. Fine. Now let us look at the development of AI through their models. I have taken it from the 1940s, 1940, 1950, 1980, 1990, 98, and so on. And the arrow is going up. I hope you are able to see the arrow. Okay. So I apologize for the small font. If you pay keen attention, you will see. So formal mathematical model was given in 1940s, particularly 1948. And today we stand at agentic AI, 222 agentic AI, and higher models. Okay. So in between, there is a long journey, and there was a halt also. There was a holiday. There was a depression that AI is not true and all. So that happened in 1970 around, because there were some scientists who came up and told that machines cannot think. So there was a lull and silence and holiday that is called as a AI winter. It is triggered as 1970 or around. Okay. So transformer is the one contribution which has come up in 2017. That is a major breakthrough in the history of AI journey. So let us take a detailed look at this arrow and let us ponder over this thing. The first test was conducted related to AI was the Turing test. Alan Turing, he was a scientist, a mathematician, and a cryptographer. Probably he's a cryptologist. He was doing lots of work on the computing machinery and all. And he's the one, if you remember, in Second World War, he decoded Enigma crypto text and enemy text he decoded, and he is Alan Turing. Alan Turing, he tried to do an experiment called as a imitation game. This was the first breakthrough to analyze the intelligence of machines. What he did is he asked the computer to generate the text, and he asked the human being also to generate the text. And another human being was sitting here, and he has to distinguish between the text generated by the computer and the text generated by the human being. And this guy, third guy, used to compare this thing. And when he is not able to compare and distinguish the differences between the two texts, then he would say that machine has produced intelligence because it is indistinguishable. Then this game was called as an imitation game, and he published a paper on this idea, imitation game. So this was the first, this is observed and benchmarked as the first step during the modern AI thinking. That is in 1950. Okay, and these were the great brains sitting in the Dartmouth University, and they conducted a conference around this thinking, whether the machines can be made to think and whether we can have imitation possible and other things. Okay, these are the great guys who started a pioneering thinking in intelligence. Computers were taught as an electronic brains, term artificial intelligence coined by the John McCarthy. John McCarthy is the one who gave the word artificial intelligence. And John McCarthy created a Lisp language, LISP. Okay, this was the programming language used earlier to create some sort of intelligence. So contributor is John McCarthy. So I'm just trying to record the historic timeline for the benefit of the listeners, because as my topic is introduction to AI and its evolution. So evolution started 1940, and the 50s you will see that AI term was coined. And in 1960s, there were attempts to move beyond toy domains. So far, artificial intelligence was restricted to only toy games. In 1960s, it moved away from the toy games, and one expert system was created called a Dendral. If you can see the text, there is something called Dendral. Dendral is the major contribution. So what Dendral did is it analyzed the spectroscopy of chemical substances and formulas, and it was able to study those formulas. So that was the contribution of that expert system, and it is benchmarked as one of the milestones in AI history. So this was happening around 1960s. And in 1960s itself, there was a German scientist called Weizenbaum. He created ELIZA to demonstrate that the AI is not true. Till then, there was a hype. Dendral was there, and coupled to a Dendral, there was one more called as Mycin. Mycin was the program or the intelligence created to study the medical related issues. So to predict the diagnostic issues. So when this was happening, people started thinking that machines can think, and we have created intelligence, and there was a lots of hype. But then there was a criticism came. The perceptron model which they were using, it was not able to separate the non-linear boundaries. It was able to separate only the linear boundaries. For example, exclusive OR gate. If you imagine a two input exclusive OR gate, and it will give, whenever there is an odd one, it will give the output 0 0 is 0, 0 0 1 is 1, 1 0 is 1, and 1 1 is 0. If you take this output on a plot and try to separate it by a single line, you cannot separate it. This is called as a non-linear problem. So non-linear problem was not handled by the perceptron. So this was a greater setback, and people thought that it is not intelligence. It is not able to separate. It is not able to emulate exclusive OR gate. And on top of that, this German scientist, he argued, and he wrote a program wherein he questioned the machine by some repeated questions, and the machines were answering. They were writing programs such that if you can, it will give the feeling of interaction with the machine. And nowadays we see that chatbots are working very effectively. This chatbot's younger brother was generated earlier in 1960s, and people were very enthusiastic, and they were in the seventh sky. They were very happy. But this German scientist, Weinbaum, he created a program and tried to question it, but found that bot was repeating itself. The questions, when he questioned, it fell into a loop. For example, I have that slide for you. Can you see this slide? Alice versus Eliza. This was created by Weizenbaum, and Eliza asks, "I am Eliza." Alice replies, "I am very pleased to meet you, Eliza." Then Eliza replies, "How can I help you?" Then Eliza says, "Just keep talking to me as long as you can." Eliza replies, "Do you wish to as long as me?" Then Eliza says, "Okay, I will as long as you." Eliza says, "Do you wish to will as long as me?" Then Eliza says, "Okay, I will as long as you." Again, Elisa asked, "Do you wish to will as long as me?" So I see the loop now. Earlier, few sentences were looking like reply, but afterwards, the looping is taking place. Repeatedly, the same question, same answer is coming. Then Weinbaum disproved that computers will go berserk and they will fall in the loop, and this is not the actual intelligence. Intelligence will be propagating forward. It is not propagating, it is stuck in the loop. And this criticism was very unanswered, and there were a setback, and there was a depression and depression period for all the scientists, because Weinbaum became true, and there were no arguments for that. So this is called as a lull period or winter period in AI. Okay, but to answer to that, back propagation came into existence. So the AI winter period was 1980s. I did not tell about 70s. 70s, there was something happening. As I told you, 1970s is recorded as a design of expert systems. And using expert systems, Mycin and like systems were designed. But this Weizenbaum's criticism put a lull or put a setback to the scientists. And there was a 1980s is called as a black period, you can call as a winter or a holiday period. Nothing much happened during 1980s. But in 1990, what happened is the back propagation was designed. The idea of back propagation came, and the output was given back to the input perceptron, and it started correcting the error and adjusting the weights. Because of that, the nonlinear separability was made possible, which was not possible in the perceptron. In nonlinearity was not possible in the perceptron. Because of back propagation, they solved the exclusive OR gate problem. Okay, once it was solved, then multiple neurons using the back propagation and hidden layers and the harvesting season started. Then again in 1990s, you will see there was a boom, and artificial neural network was coined. So millions of networks, hidden layers, blah things started happening during 1990s. Added to that, in 1997, greatest achievement, important milestone, a computer defeated Garry Kasparov, the chess champion, human chess champion, was defeated by IBM's Deep Blue program. So then scientists accepted that we have got a milestone achievement. So intelligence can be created in machines, and the work started exponentially growing exponentially from that day onwards. So just to keep the timeline straight, just to summarize that, so 1950s Turing test invented. First AI winter fell in 1973. I told you the background. Because of Weinbaum's criticism, nothing happened. In 1980s, boom times started because of backpropagation invention. Then second AI winter came again in 1988. Okay. Then 1990 onwards, people started working. And in 2012 around, I did my PhD in around 2012. And I used lots of deep learning and machine learning stuff using genetic algorithms and other things. So the history of that was the AI intuitions. Okay, so the students who have done their master's degree and after 1990s, they have played with all these machine learning and AI stuff, and there is no stopping now. It is growing uh, very positively. 2012 deep learning revolution, 2019 and 2023 and all. This is the timeline. Fine. Today, where do we stand? Look around. We talk about lots of keywords called robotics, self-driven cars, natural language processing units, sensors, plannings, knowledge-based systems, ontologies, and blah, blah things. This is all happening these days. So just to benchmark the AI models, so I have given you a slide here. The AI models that contributed for the today's AI evolution. So you will see the perceptron, then backpropagation using artificial neural networks. Then you have one network called as a CNN, convolutional neural networks. Those who are working in the image processing area, it is a hero network for them. It is a very handy Aladdin network for them. CNN. So it does image processing very beautifully. Okay. So the idea is passing the image through various filters and analyze it and classify it. Okay. Then after CNN, then to address the sequential nature of the data, then they came up, they modified the artificial neural networks into recurring neural networks, RNN. We called them as RNN, just to handle the sequences. So human sentences or speeches, they are in the form of sequences. So to comprehend those sequences, we need something to be remembered, what we said previously. Okay. At least a recent past must be remembered. Otherwise, we'll talk mad. We'll talk like mad people. So mad people don't remember the previous thing, what they have talked. And even the children who have no idea about what is the topic, you can listen to their talks. They talk very randomly because they don't remember the context of the past. So it is very much essential that in sequential data processing, you need to remember the past. To make them remember past, they designed a network called a recurring neural network. Okay. Then there were some problems in recurring neural networks. I'm just showing you the next slide. So the model evolution, what are the models that have evolved? Artificial neural networks, as I told you, CNNs for image processing. Then for sequence processing, particularly the text and language translation and all, RNN were designed, recurring neural networks, which remembered the past sentences depending on the context. Then they wanted a little bit longer remembrance and lighter circuits. Okay, so this was a heavy circuit with lots of stages of memory and all. They converted it into a gated recurring unit. Okay, they reduced the number of gates and they modified it as GRU. It is known as GRU. It stood for sometimes, and researchers are using still these networks and implementation of them. Then in the context was when it is a paragraph, it has to remember. The context was expanded and we need a longer history to be remembered while processing. So they called it as a long short term memory. So it is a bigger brother of RNN only. RNN's bigger brother. So the idea here is when you are talking going forward, you should remember the past. If you don't remember the past, you cannot go forward meaningfully. So history is always important, whether for humans or whether it is for data processing or whatever. The better you remember the history, the better you will process the future. That is the philosophical idea. And it is true for data processing as well. So in RNN, small yesterday was remembered. In GRU, they made it to remember a week back. In LSTM, I wanted to remember a month back history or an year back history. So they created a long short-term memory. And this LSTM is again explored to create the modern day transformers and all those things. So I have collected some points here regarding what I showed you here. Pitt's neuron and Hebbian learning and all. And for paucity of time, and I may not go through bullet by bullet here, but that's what I wanted to say. The summarizing is the models also have evolved. Not only the thinking has evolved, the models also evolved. And we have caught the cat rightly. We have caught the cat very rightly, because to process intelligence, I need a history. Okay. And history can be captured through RNNs, GRUs, LSTMs. And that led to many applications like language translation and all. Whatever you see, Google translates and all, no, they have resulted because of that. Now, notwithstanding to this, they wanted to capture the data in a bulk, huge GBs and terabytes of data, and process it. Was it possible through the sequential idea of thinking? So it was not possible in a sequential process. So they thought the parallel processing is important. Okay. So there comes the use of transformers. I will come to the transformers. Before that, another model that I had shown you for CNN, convolutional neural networks. So in my research, I used the convolutional neural networks and deep learning. And there is a cancer detection paper laying in the Google. You can see against Ali Kadampur. If you search, you will get a good paper, which I used CNN and convolutional network to classify cancer images. And many of you who are working in the front-end research might be using internally. And there are modified versions of this CNN. And probably in the detailed discussions in the coming days, some of your experts may be touching in depth about these circuits. Okay, my job is to just touch the surface and kindle interest in you, and form a historical perspective for the forthcoming days. Fine. So keeping that in mind, I'll move ahead to my slides. Mahesh, I am with you. All are with me.
Sir, yes, sir. It is extremely good, sir.
Because,
Yes, sir.
yeah, because I'm sitting alone and talking to the laptop, which is going crazy for
No,
me.
sir.
Yeah,
You are
fine.
explaining beautifully, sir. Okay, sir.
Yeah, fine.
Okay.
It is going well. Yeah. Well, as I told you, I will not touch upon each bullet points. So you can go ahead and timeline tracing. LSTM was introduced in 1997. Core idea was gated memory cells. Contribution was long-term dependency learning. As I told you, we wanted circuits which can remember as much as possible. If you tell a story in a paragraph, at the end of the paragraph there is a word. Okay, they visited Himachal Pradesh and they enjoyed something and they had a party and they enjoyed the falls and they ate some bananas, something like that. Okay, my sentence has ended. Who has eaten the banana? Want to know. When I reach the word banana, I want to trace back to the person who purchased banana. What is the description of that in the paragraph? So I'm tracing back to 5 or 6 or 7 sentences back. So it is a challenge for remembering. So long-term memory was required. So not only one small paragraph, entire text must be remembered to predict the next level of thinking. So this was the challenge, and this challenge is being addressed till today. This is the modern day challenge. So if you can remember the entire universe in one go, then we have become a super intelligent creatures. Because if we can process entire the data available in the universe in one go, then there is nothing like that. On that day, we must appreciate and we should pat ourselves that we have created super intelligence. We are moving towards that, and the transformer architecture is one such breakthrough benchmark contribution in that context. I will come to that transformer. Yeah, well, transformers. The difference between RNN, LSTM, GRU, and transformers is transformers started processing in parallel along with the sequential processing capabilities within themselves. They will take all the words and encode them. They will not take one word by one. All the words in the sentence, they will take at once and they will encode them. So basic idea between in transformers is detailed paper you can read from Vaswani, great person. I highly appreciate him. He has contributed this. Microsoft engineers, there are other 7 engineers. They have given this idea. So the idea is why to wait for each word to come one by one in a sentence. Take all the words and encode them first. Then at the output, you decode them. Then you will get the context. Then to get the contextual meaning, they gave an idea of positional encoding within that. So with all these ideas put together, they gave an architecture which is popularly known in the research domain. I hope you are able to see the idea, the architecture. It is called as a self-attention architecture. Self-attention, what it means is the word that is currently available, it will question the previous words. Not only one word, but it will question the previous all words. If it has traveled 5 words ahead in the sentence, then the 5th word will question the 3rd word, 4th word, 2nd word, and 1st word. So it will question them and get the answer. Okay. Ram and Sita traveled in the forest. Then forest will question the previous word Rama. Then forest word will question Sita. The Ram will forest word will question, and also it will get the answers from that. The questioning terminology is given as Q. Okay, and what it is questioning is called as a key, K, and the answers that it gets, the questioning entity, is called as a value. So they termed Q, K, and V. So query, key, and value. And it is a common sense process. Whenever you want to have some information from anybody, if you are standing in a bus stand, if you want to go to Mysore, or you are already in Mysore, if you want to go to Mandya, then first thing what you have to do is you have to question somebody whether this bus goes or not. So there is a question, Q. Then what is the key that you are generating for getting that answer? The key is the question, like Mandya. You want to go to Mandya or the Ooty? So if you are going to Mandya, Mandya is the key there. So there is a key entity required to get the search done. Then the opposite person, he will reply, no, this bus doesn't go, is the reply. That is the value. So each word, when it questions its previous word in using this model of QKV, I'm explaining in a very abstract way. The detailed mathematics and jump is not the scope of this FDP or the session, but in the detailed involvement, we can take it up. But in an abstract way, I'm trying to give the analogy why this Q, K, and V terminologies are used in this architecture. Very interesting and very great work done by Vaswani. So each word in this will get answers, and it forms the vectors. So each word will have 3 vectors, Q, K, and V vectors. And they will be dot produced, or the dot product of them will be taken, and a new vector will form, and new vector will be propagated further. And this way, the architecture continues. This is one of the greatest contributions of the modern era to artificial intelligence, which is at the core of your chat GPTs and all the AI tools that you are studying or using these days. Okay. So every AI student, I want them to explain this to, should be capable of understanding and explaining this paper. Fine. You take time out. If you have not studied, you please study this. It is a very interesting contribution and a very interesting paper. If you are able to understand this paper, that means you have made your journey in the AI domain. So even at the end of this workshop, I advise you to read this paper and understand this architecture. So in the context of benchmarking the milestones, so I have brought this transformer architecture, which is different from RNNs and LSTM in the sense that the data is processed parallelly here. Okay. And now this is at the core of the LLMs, large language models. Large language means what? The language, entire corpus of the language available in the universe. All the English language, textbooks, Wikipedias, all words it will be able to process. That is why ChatGPT, you ask any question, it is able to reply because immediately it reaches to the corpus of that language and it brings out the values and shows to you.
Ali sir, sorry for
Yes.
disturbance, sir. The time is nearing 8 p.m. and Dr. Abhinandan is waiting for another session. Actually, your session is nicely coming and it is exceptionally good. So I'm really
Yeah.
sorry for and telling this that is
So
time limitation.
can I just conclude in 5 minutes?
Okay, sir. Okay, sir. That's fine. Sir. In 5 to 10 minutes, try to conclude, sir.
Maximum how much you tell me? 5 minutes or 10 minutes?
10 minutes, sir. You can take 10 minutes.
Okay, 10 minutes. I will conclude in the 10 minutes.
Okay, sorry, sir.
So, yeah, thank you. Thank you. I understand the importance of the occasion.
Okay, sir. Okay.
Yeah. Because we are teachers, if I get lovely audience, it continues. It continues for hours together. Okay, apologies for that. Now I will rush. And if there is any missing link, apology for that. Yes, this is LLM and all. You can study these things. This is not a new literature. But anyway, LLM is at the core of your modern day chat GPTs and AI tools. And this is generative adversarial network. Probably I saw that in the itinerary. One resource person will be talking in detail GAN architecture. The idea is again given by an Israeli scientist, and two models will be contradicting each other till they get the truth out. It is like a police inquiring a thief, whether you have stolen this, whether you have stolen that, whether you have stolen this, and so on. So adversary and the generator will be talking to each other, and the model gives you the output. The idea is around this thing. Details, our speakers will tell you implementation of things. So GAN, I am using actually GAN in drug discovery and material discovery. It's a very important network which can be used in new material discoveries because randomly it produces material prototypes and you can test them in the wet labs and come out with the new materials. I will be showing one slide where it can be applied in the context of intelligent material generation. Right now, I am using it for new solar material I want to investigate. Apart from the existing photovoltaic materials, better and efficient materials I want to utilize, and GAN can be used. But mainly GAN is used for image generation. These days, crazy image generation, they will put one or two images and they will generate the third image. And that gimmick is happening in the AI field. But as a researcher, you should go in a useful domain and try to use these networks. I am not finding much research happening around new material creation, new object creation, new thought creation, something like that. So it is a useful network to be applied in material discovery. Fine. Having said that, the current trend is AI agents and agentic AI. Difference between AI agents and agentic AI. I have shown you the slide. Those who have some confusion, these are the meaningful slides. So we use one agent to achieve one particular goal, whether it is booking a taxi or booking an air ticket or something like that. I use one agent. But if you are using a group of agents to accomplish a complete travel itinerary, booking ticket, booking lodge, guiding and explaining you the visited places, then escorting you through the airport and all those things, all these activities are being used or are being accomplished by different agents, then it forms a agentic AI. The words, if you put the reverse way, it becomes a group. The combination of AI agents helping you to achieve certain objective, agentic AI. So we are in this domain right now, agentic AI and AI agents. Fine. So next leap will be the quantum AI. So when the data volume is increasing enormously, then the present day GPUs or present day architectures may not be able to handle the data. Though your architecture may be proper, but the data when it goes very enormous, then the current strategy may not be sufficient in the coming next 10 years. So we are preparing for that. So what we are doing is quantum AI. And I'm happy to learn that Bangalore and even particularly India is spending a lot on quantum research. So you can combine quantum and AI, and you can come up with the quantum AI thoughts. Fine. So I have a paper in quantum biosensors. I have used quantum AI for generating new biosensor materials, which can be used for pathogenic drug discovery. Fine. That is the area. Those who are working in research areas, these are some key terms that you can take away. Quantum AI and related problem solving. You can apply it. Well, useful tools for AI for practitioners, just an out of thought. So I'm showing this slide. You can take a screenshot and you might be using few of them. So at least 10 AI tools everybody must know. You can keep a competition in your classroom. Who knows more AI tools? Just names and their purpose. Now it has become mandatory for every AI engineer to know at least 10 AI tools. Okay, so the AI is happening with a low code, no code, and it is a no code era. These tools will help you to develop applications using no code. The first PPT that I showed you, I used these tools to generate that PPT presenter, which I showed you in the beginning. Fine. You can form the workflow using these AI tools and generate very interesting applications, which can solve the real-time problems, whether it is agriculture, medical, or educational, or anything. Okay. So I advise you to go through these tools. Fine. Then I have made a long list of these tools for the benefit of the listener, but I will not go through in detail because of paucity of time. I'm already been alarmed for 10 minutes time. Okay, you can just go through these tools. So what I'm saying is you have a bag of tools in your pocket. It means in your mobile, you should have those icons available in your mobiles these days. Don't keep only WhatsApp and Facebook. So try to keep all these minimum 10 AI tools in your mobiles, which are relevant for your work and research. Well, application types possible with AI. So just I want to kindle some thoughts for the master degree holders and some researchers. So like AI tutor for competitive exams, you can create an AI tutor, automated AI tutor, because students prepare for NEET exam, UPSC exam, JEE exam, AISSE exam. So you can create a tutor bots for competitive exam preparation. Doctor companion you can create. AI bot can diagnose the disease by listening to voice message of the patient. So it acts as a doctor companion, because ChatGPT will give you lots of diagnostic details. It analyzes lots of medical data. So using that, you can generate such companion diabetes. Okay. Resume and career builders, material discovery, as I told you. Then personal finance, AI advisor, stock and share. If you are handling, you can use AI. Agent for small shops and local business. Language translators for hospitals and courts. And co-teacher and content generator for schools. And my twin at college pedagogy. So you as a faculty, you can have your twin in your voice, and in your image, in your video. You can generate a model which narrates the PPTs. Probably if we invited in the next time, probably I will not give the presentation. My image and my video will give the presentation. So I will create such a my twin at my college pedagogy. So I am advising the teachers to create their own twins. And whenever you are taking a leave off from the college, and if the principal and HOD is not permitting on the basis of not taking the class, then you leave your twin in the college. He will teach on behalf of you. That is what I mean by AI my twin. So these are very ambitious and very interesting projects which can accomplish. Okay, just kindling your thought. Okay, and research titles possible. Yeah, your PhD guides will guide you on various topics. And if you come to me, then probably I will have enormous ideas. These are some research title possible. And the font size is very less. Thankfully, I will not go through, read them. And next, discover of intelligent materials. Yes, why I introduced materials is the GAN network can be used, and new materials for intelligence. See, algorithmic development and architecture changes are happening. That is creating new intelligence. But at the material level also, if you touch and come up with a new material, apart from silicon, whatever intelligence we are having is right now is a silicon brain. Can I think of any brain other than silicon? It will be a better brain than the present brain, because human brain is better than the brain of an elephant, brain of a tiger, right? Why? There is some material difference between the human brain and the brain of a tiger or a monkey. Okay, so there is a focus on coming up with a new material for intelligence. I quoted it, quote unquote. I want to see some research taking place for generating new material for intelligence. How it can be done? So you can make the GAN use, GAN you can use, and the existing material structure formulas, chemical formula that acts as a standard input, and randomly the wizard will generate the material structure, and it will compare whether it is adhering to the existing chemical formulas and this thing. Then it will pitch out the new material. So if it is creating new intelligence, fine, that will be one of the breakthroughs. The work has already happened in this direction. Memory star based materials, organic polymer computing, okay, quantum spin lattices. These are few words with respect to new intelligent materials. So the listener and attendee of this workshop can take these thoughts forward. Okay, I leave you there. Just to wrap up, AI evolution, as I told you, it is not the process which has started recently. Civilization have contributed to this. I find the context of Kannada and Karnataka contributing to AI in the form of various. I have listed the intelligence layers and phases. Vachana Sahitya, then Sharana assembly, Jaina multi-valued logic, then morphology of rich language. Kannada is a rich language. Language itself is an AI contribution, manifestation of intelligence. Folk ecological intelligence, Anubhava Mantapa that was there in Basava 12th century. These are all, if you can relate the analogies, these are all the outcomes of some kind of intelligence. So we see the intelligence progressing through these developments. And I could have gone into the minute justification of why I have selected, but because of paucity of time, I leave the thought there itself. And if anybody wants to contradict, we can have a separate discussion on whether this is a contribution of Karnataka in AI or not. You can debate and write this paper. This title itself becomes a research paper. You can write AI glimpses in human civilizations, a historic mapping, context of Kannada and Karnataka. This is the title of your research paper. Somebody can dig some material and come up with the paper. Similarly, I see historic mapping in every civilizations. Since I'm staying in Saudi Arabia, I generated the context of Arabs. In Arabic history also, you will find glimpses of intelligence being created. For example, Arabic linguistic precision. Okay, any society that speaks language, that means it is intelligence. Okay, algebra, as you know, algebra was created by these Arabs only. Okay, Al-Jabr, his name was Al-Jabr. So algorithms are contributions of Arabs. Okay, in Quran, I am a Muslim, so there is a Tawheed and Kalam. And those who read Quran, they appreciate the rhythm and the arrangement of what we call in Kannada Chandasu, and that no, it is very beautifully narrated the story. So it shows that the text itself, whether it has come from God or not, it is a believer to accept. But the way in which it is coined, it's a very special book. Those who read it, for example, if you read the book of Ramayana Darshanam, Kuvempu, you see the words, how they are arranged in that. So that shows the intelligent arrangements. Okay. So these are all contributions of civilizations in the perspective of intelligence creation. So I don't say that intelligence started created in 1940. Before that also, there was a contribution towards intelligence creation. And context of India, if you take in the larger perspective, the Indus Valley civilizations, and in the Panini is one scientist or one linguist who has given the grammar for literature of India. Panini is. Then Arthashastra, Kautilya's Arthashastra. Then Nyaya Sutras that are available. Okay, these are all, and zero invention itself, formal symbol systems, zero place value decimal system. That is the contribution of intelligence by Indians. So these, if you see now, you appreciate intelligence progressing in human civilizations, time immemorial, gradually, sometimes very fast, sometimes in other directions, and sometimes now we are standing at the computer-based data processing and creation of intelligence. So we should pat ourselves having been Indians, and particularly in the domain of artificial intelligence and studying in our respective domains of computer science and artificial intelligence. Okay, we should be thank ourselves and blessed to be in this domain. Fine. So this is the ultimate evolution ladder I am showing, where it is leading towards. So I see that we are standing at the earlier individuals used to research and invent. Then the group used to invent and do. Nowadays, it's all about collective intelligence. My data is there in the internet. Your data is there in the internet. Every human being's data, dead or alive, his data is there in the intelligence. This is all giving rise to collective intelligence. We have stuck at the collective intelligence now. So we are processing the collective intelligence that is available in the entire universe. Then we move towards quantum intelligence. We try to process the intelligence largely available in the universe by using quantum devices. Then this will lead to cosmic intelligence. So I am seeing the path, the perceptron, the intelligence creation that started with perceptron, artificial neural networks, RNNs, CNNs, transformers, LLMs, AI agents, agentic AIs, then collective intelligence, quantum intelligence, and it will move towards cosmic intelligence. That is what I am envisioning the ladder to reach to. Once we reach the cosmic intelligence, probably we are unifying with the creator. Okay. So that is the way. It may take time, another 40, 50 years we may go. But we are right now in the era of collective intelligence, and quantum intelligence is breaking through. That is how the evolution is moving towards. I perceive it like that. Fine. Conclusions. There are many conclusions. Nature of intelligence. Fine. On nature of intelligence, we have neurons, and both we debated that non-living things also may have intelligence. And the model evolutions we have seen ANN, CNN, RNN, LSTM, and so on. Then role of IoT, actually. The collective intelligence is coming from non-living things also, because Internet of Things is trying to network the humans along with the non-living things. And whatever data is emanating from the non-living things is integrated with the data emanated from the living things. This is possible because of Internet of Things or IoTs. Okay, so the role of IoT is going to be seen in the coming days. Civilization mapping, we saw the civilization mapping. We argued that intelligence is not the modern day contribution, but it is being generated time immemorially in various civilizations. We have seen Indian civilization, Karnataka civilization, as well as Arab civilizations. So future intelligence materials, yes, we focused on the new material generation for intelligence. We don't stick to only silicon brain. We want to think about creating a new material and apply the same architectures and see the performances. Architectural modifications, algorithmic modifications are going on parallelly. But if we can come out with some new material and it will break through, it will give a very substantial leap for AI, I feel. So on that note also we discussed something. So future intelligence materials. Then practical tools we have seen like N8N, JPR, and I have shown you some practical tools available. Okay, and the Gemini is one thing, ChatGPT is the most popular one, and blah blah things. Okay, the next 20 years you will see these trends will become multimodal. AI will become multimodal, embodied with robots and autonomous machines, IoTs, robots. We all become members of one family, of intelligent family. Robots will not be different. A drone flying with automated control will not be different. It will be talking to me, it will be talking to my brother, it will be talking to my sister. So we all become embodied. So it becomes multimodal. Integration with quantum computing, the intelligence will get processed from the quantum computing. Already, I have seen huge investments coming up in Bangalore and in Andhra Pradesh, particularly Amravati. Andhra government is spending much on the quantum computing, and new courses are getting designed in the quantum computing. Probably MIT can think about a BTech program in quantum computing. That is a possibility. Now, last point is ethical frameworks will guide now. Ethical is a big issue, and humanists and ethical moralists, they will think on ethical frameworks, which is the boundary between man and machine, job loss, and market pressures because of AI, economic pressures, and blah blah things. Ethical frameworks, marriage issues, because these days female robots are so beautiful, and those people are reaching to marry them. I have seen in some international workshops. So these are also all some ethical frameworks that are to be discussed in the coming years. Okay, next 20 years will be on that. So AI is therefore not an anomaly of 21st century. It is the latest rung on a long evolutionary ladder that connects. Now AI, what it connects is non-living matter, living systems, human cognition, collective civilizations, and engineered intelligence. To understand AI, one must trace this ladder historically, materially, and philosophically. I hope you agree all. And these are my references. And we Indians never end without appreciating the people who contributed. I thought I should show you the main scientists who contributed in this field of AI so far. Hats off to them, and namaste, and thank you so much for these people. And you can read their names. And here is my current favorite, who is Ashish Vaswani, who is the architect of that paper, Self-Attention. And of course, I am thanking Guido van Rossum, who has given us Python language. And you know that Python language is being used in AI enormously. And Sam Altman is the founder of ChatGPT. I have taken his photo as well. And these two scientists, John Hopfield and Jeffrey Hinton, they did a lot of work in neural networks. They were awarded a Nobel Prize. These are the people. And the Turing is here. Okay. And the person who coined AI term, the artificial intelligence word, is John McCarthy. He's the one here in the fourth position in the top row. And the person who gave us perceptron, he is here, Rosenblatt. Rosenblatt, and McCallum Petit also is there, but perceptron contribution is listed against this person. Okay, so this is how the human contributions. Hope this contribution will grow and humanity finds a better place to live. They make Earth a better place to live, and that should be the objective. As I told you, the material alignment should take place at the microstructure with a particular objective of making the life better on Earth and elsewhere. That should be the goal of AI. So when I make this statement, again, I'm bringing the ethical debate. Okay. On that note, I invite your questions. And if there are any questions, there is no provision. I think your voices are muted. But you can pass to the organizer any questions. You can feel free to contact me at my email, which is displayed in your posters, or you can reach out through Google. I'm not a very conspicuous person. I am available in the Google. You can search my name, Ali Kadampur, and if you've got any queries, I'm happy to interact with you here, even in the future. With that note, I thank Dr. Mahesh. And also, I want to thank all the resource persons who have arrived at this FDP. I have seen their contributions. Dr. Mahesh Huddar and Gajendra Deshpande, particularly, he does lots of work in cyber activity, cyber security and all. Youngsters and all the participant faculty. And I want to thank them enormously. And let the knowledge world grow, and let us be intelligent to adapt to ourselves. And yes, Mahesh, Dr. Mahesh, over to
Sir.
you. I'm
Yes,
done
sir.
with my
Yes, sir. Thank you so
presentation.
much,
Thank
sir.
you.
Actually,
Thank you for the opportunity.
your presentation was exceptionally good, sir. That is the evolution of artificial intelligence, and you explained it from way back to 1960s, And till now, that is quantum AI, that is very important for all of us. So
Yes.
definitely, sir, we are planning to conduct one FDP on quantum AI. Definitely, I'm going to contact you, sir, in this regard in future. Thank you so
Okay.
much, sir. Thank you so much, sir. Thank you so much.
Thank you, audience. Thank you, one and all. So may I leave now? Yeah.
Yes, sir. You can leave now, sir. Yes, sir. So next, we have Dr. Abhinandan. Sir, are you there?
Yeah, I just want to
Yep,
be
yep, yep.
there for 10
I'm
minutes
there.
and
I'm there. Yep. Hello.
Okay, sir. Okay, fine. Let us welcome Dr. Abhinandan SP. He is a professor in the Department of Data Science, IIT Palakkad. I just want to introduce a few things about Dr. Abhinandan. He has published a number of international journals, which comes under very good publishers. So now I request Abhinandan sir to give lecture on fundamentals of machine learning. So I request all the participants to be here only. Don't leave the meeting. So we are going to record your attendance in sorry, in Zoom. So I request all the participants to be with us just for 60 to 65 minutes. Abhinandan sir, you can, sir. You can.
Yeah. Possibly I aim to cover rapid by 9:30, so I can understand.
Yes, sir. Yes,
It's
sir.
already night, right? So feel free to stop me if you have any questions. So
Sir,
at purpose, yep.
till
So
9:30 you can do, sir.
yeah, that's what it is.
Okay.
That's what.
Okay. Okay, sir. Thank you, sir.
Yeah. So okay, today we'll talk about the fundamental of machine learning. Before that, good evening to all of you. So this is a little bit different. So the flavor is a little bit different since most of you are faculties and then the PhD research scholars, right? So my whole idea is to look from the perspective intuitions. So how does we literally learn from how the machines literally learn. So most of us are teachers and we know what the learning is. The interesting perspective is that how does machine learn? So that's the whole idea that I have in my mind when I wanted to give this session. Uh, so I hope you can all see my screen. So as I told you, it's very simple. Understand the concept of learning, differentiate what do you mean by training and testing. Uh, Possibly we are not going to do with the linear model because when after creating the slide, I thought, okay, we will let a few of the things we just gloss over. So basic idea is I wanted to deliver a talk on two things. One is what do you mean by learning from the perspective of machine, and then what's the differentiate between training and testing. Here I assume that you guys have access to libraries and at least have some programming experience with Python. So today, most of the machine learning software frameworks are commoditized. You just go it and in Google or in Chat GPT, you will get a lot of examples which you get it up and running. So what I thought was, okay, that's almost commoditized. What we can do is that can we go a little deeper into it? That's where my objectives for today's this session. It is little bit mathematics, but not the gory details of it. So feel free to stop. So let's start. Okay. So this is the one where from today, right? From no, machine learning is no longer a technology which is in isolation, right? Today, when we start get up and then till we sleep, we use a different kind of applications, right? So we do have the alarms, phone. So most of the time, it is not like the regular alarm clock that we were using when we were kids, right? Everything is smart alarm, and then you can configure a lot of stuff, right? You can make it learn, and then when we are commuting, we'll have a forecast which actually talks about how the weather is and all those things. And then when we go, most of us use our biometric, right? Especially coming to the college and then having a biometric validation just before the time, right? 9:30 in some colleges, 10:30 in some colleges. So exactly those are the things. And then based on that data, so basically what we are doing here, right? We are integrating the devices and getting the data and using the data to find the patterns, right? For example, if you talk about the shopping recommendations, right? When we just log in into our Flipkart or Amazon Prime, we would get the list of products which we might be interested, right? And then the other thing, the most important stuff is OTTs, right? That changed the world, and the way we have the environment has been completely changed because of Netflix, right? So these are the things. So if you see, when I just log in my into my Netflix account through my mobile or through laptop, a lot of things happen underground, right? Under the hood, for instance, like with the recommendation. And then when I click on the movie, if I am in mobile, the automatically it selects the resolutions, right? If I'm on biggest TV, it automatically takes another resolution. I need not go and change it, right? So a lot of the things, and then we have a Apple Siri, and then Amazon's Echo. So a lot of things are there, and as I we can easily see that machine learning is into everyday's life, right? So let us try to understand a small, briefly, the overview when all it started. And all it started in thanks to Alan Turing. Most of you might not known. Alan Turing was born in India, Madras Presidency. Even though he is British, his parents were his parents were in India just before the independence, and he was born in our own backyard, Madras. And amazing contribution. And still, no matter the Chat GPT, even in the Chat GPT, could not still pass the Turing test. So no matter, we apparently see LLMs are becoming more intelligent, but unfortunately, they are long way to go to pass Turing's test, to categorically to call themselves as intelligent, unlike like humans. Okay, so it was very interesting. So when if you are teaching introduction to AI course, right? Russell Peter's book will actually talks about this kind of Turing test, which is very interesting. And then we started in 1950s, 70s, and then once the cloud came, thanks to Amazon. Amazon could monetize the cloud, and based on that, we got the required compute capability. So that enabled learning, handling the large amount of data. So we got a facility to handle the large amount of data. Basically, it is like a container, right? You got a very, if I want to prepare any feed dish for 200 or 300 people, I need to have a bigger container. Then only, even though I know the recipe, right, I cannot cook it on small utensils. I need a bigger kadai. For example, if I want to prepare Mysore pak for 1,000 people, I cannot do it on small container, right? I have to do it on the large kadai, and I need to have the scalability and all those things, right? So cloud provided that infrastructure, and then machine learning and AI never looked back. So this is what we are going in, and still we are. So okay, yeah, AI and ML are going further. People have a lot of opinions, and then so the one thing that we are touching, probably we might have the saturation with respect to the compute capacity. So that's the where still we might hit the roadblock. That's what the idea is. So let us try to understand what do you mean by um, what is the difference between artificial intelligence, machine learning, ANN, and deep learning, right? So most of people will equate AI with ML, which is not the case. So basically, AI talks about any techniques that enables machine to think and behave like humans as we do, right? As we do, like uh, uh, we think about any problem and come up with our solutions, the approach, and all those things. So basically, if you take, right, what differentiate between the agents and the humans is, see, even when we don't have the data, we do have the gut feeling, right? So even if we don't know the map, we can still reach our destination through compass, right? So that's the capability the humans have compared to the machine. So machine requires map to reach its destination, but humans can figure it out by their own. This is trying to coming up near that is the idea of the artificial intelligence. Okay, then what is machine learning? So in machine learning, what we do is we give the data and we'll ask the computers to figure it out. The rules and the patterns that's very difficult to program. So we want the computers to figure it out. Okay, and then artificial neural network. It is a more like a bio-inspired machine learning, how the neural networks and all those things. And deep learning is a subset, which which automatically does the feature engineering. So you can see the artificial intelligence as a bigger umbrella, and then the machine learning and the deep learning are inside each other, right? If I take the Venn diagram, artificial intelligence is outer circle, and the machine learning is in the inner circle of artificial intelligence, and the deep learning is another circle inside the machine learning. So then what is a common? So the common is learning. Okay. So as you know, this one is a figure of a tree. Agree? So now tell me, how do you define a tree? Can you message me? Let us make it more interactive. Uh, can we have the chat window open, and then the participants can chat, mm, or can any one of you tell me how do you define a tree? How do you define a tree? What does trees have? Okay, let us ask our coordinator Mahesha only. Mahesh sir,
Sir.
can you define how a tree is? What a tree is? So
Sir, it has stem, branches, um and leaves get a nutrition from roots. So number of branches with the stem.
can I call this as a tree?
It is a non-living thing. It has life, but it is non-living. This one, what you're showing now, it is
So
just a
base,
model. It is just a model.
yeah, Yeah, model in the sense that, see, typically if we tell that it has a trunk, it has a leaves, it has roots and all those things, right? So the whole question is, see, if you call, see, just looking at this, if I take two figures, right? The previous figure and the current figure, for humans, do you think like how fast we can tell that there's one is a tree and other one is not a tree, which is a craft? It's pretty easy for us. Intuitively, we can do it within, even we don't think whether there's a tree or not, right? This is a craft just by looking at, we can tell. But what about the computers, right? For example, if I give like this, uh, yeah, yes, I can see Babu Prasad raised his hand. Yeah, okay. Hello. Yeah. So, given these photos, right, how does a machine wants to learn whether there's a cat, there's a dog, there's a tree? That's where we call it as a learning problem. See, for us, for humans or animals, right, it's a straightforward, right? Just looking it and our brain process instantaneously. We need not think about whether there's a real one or unreal and all those things. Think about the computer's perspective, where the computer stores this photograph as zeros and ones, which is nothing but a binary, right? So how does the binary numbers map into the decisions like cat, dog, or something, right? So this is what exactly the machine learning trying to do. And for that, the fundamental is learning problem. Okay, let us try to go to deeper. So let us take another example. So we all have Netflix OTT. Can we predict how a viewer would rate the movie? Can we predict? See, the way the prediction makes would help Netflix. The reason is they can now bargain for, if they know, if they crack the code, right? How the users who is going to review their movies, then they can purchase the higher possible higher rated movies for higher money, and not so good movies with less money, right? So basically, the thing is, if you see nowadays, even before the release, they have the OTTs have the bargain and then get a deal out of it. And most of the time, it is driven by star power or director power and all those things, right? And few times it works, most of the times it won't work at all. But still, we go with that because we don't know how the viewer would predict, right? It is now the if I take the Netflix as a simple example, it is no longer a single geographical location based app, right? It is across the world, and across the world now we not only look into any Kannada or Hindi movies, we look into Malayalam movies as well. We look into the Spanish. Spanish serials, right? So you name it, even the users are uh, divided globally, right? So it is very difficult, right? So last time Netflix had offered 1 million prize for whoever come up with a 10% improvement on their recommendation systems. So that's a huge amount, right? So just only a 10% of improvement. Think about the kind of complexity the real machine learning has, right? So generally what happens is that the each movie, when we have that, it has a lot of genres, right? It can be a comedy content, it can be an action content, it can be a blockbuster, and it has a lot of attributes saying that who is the hero, who is the heroine of the movie, and who is the director, and a lot of things. And based on that, you have to come up with a rating, and you have to make a prediction. So the whole idea is, whenever we are going to apply machine learning, we know that a pattern exists and we cannot write it down mathematically, but we have the data. The moment I write down mathematically, then it becomes a normal program where I don't need any kind of machine learning. So for example, right, if I know how the bank transaction happens, right? I just if I take the classical example is our UPI, right? We take the QR code, we just open up our any UPI app and then just make a just open the QR code scanner. It will scan the QR code, it will get the address, and it will just debit or credit money from our bank account. It does not do any kind of machine learning because it knows mathematically, I know the sender details, receiver details, and sender details. I know the corresponding amount, right? So I don't need anything else. So I can do it with a normal programming. So sometimes, right, having thinking about machine learning, applying machine learning to each and every problem is a overkill, right? You cannot use a cannon to kill a mosquito, right? Which you can do with a mosquito coil. That's a more appropriate rather than trying to bring a cannon, right? So machine learning is like a cannon, and it makes sense when you have a data and you know. Sorry for that. And then you know that the patterns are exist and they're complex and you cannot capture it, right? That's where we are going to the machine learning. So let us ask one simple example, right? We all know most of us get a lot of calls saying that, okay, you have been provided a loan for personal for some things. But the question is that given the attributes like this, how does, if I want to design a system, it would tell me whether I should approve my loan or not. Let us take this as an example and try to understand what internally happens intuitively before we use any kind of tool. Okay. So let us take X is my customer application. My output is very simple, right? Lend or reject. Why I need to use machine learning here? Because I don't know whether I need to. There is no program which will tell that. For example, if you come here, right? The attributes that you see for the loan approval, it has age, gender, annual salary, years of residence, years in job, current CIBIL score, and his past actions, like how many times he has defaulted his loan and all those things. So when you want to make a decision, you have to take all these attributes into the account. And if I'm going to write as a program, then see, I can literally do it by using if and then or having the complex rules and all those things. Still it is similar to what expert systems were doing, right? Expert systems were writing writing these kind of rules, and based on that rules they were making decisions. But initially it worked. After that it did not scale well, because if I tomorrow RBI comes up with another attribute, right, then I have to add modify my rule engine and all those things, and it will become the bottleneck. Adding the more rules will become a bottleneck. So better you give it the approved data to the system, and the system let the system figure it out, like on what parameters were considered to accept the loan and reject the loan. So this is the idea of learning. So basically we want to learn, the system needs to learn what are the attributes that's more important relative to others to make a decision to give the loan or not to give the loan based on the historical data. Like the humans have literally have the set of data where they have approved some loans, and then they have disproved the loans as well, right? So output, I want to whether lend or reject, and the target function I want to see is create approval formula. What is the formula that I need to apply? If I put that formula, I will know whether I can reject the loan application or accept the loan application. And the data that I have is an historical data, right? So from past for 2 years or 5 years, I have the historical data of various applicants and whether we have lent or rejected. And you feed that to a system. So the question is, what is the formula that is going to use, right? We want to learn this target function f from the data. Okay, this is what typically a machine learning tries to do. It wants to learn the target function f from the data that you have given. So what we do, all we know, right? We all have some kind of uh, research experience, and we know that we have a hypothesis. What is an hypothesis? We make an assumption, guess, saying that okay, given some situation, a situation that is observed, we come to a conclusion. So the reason might be X, reason might be Y, reason might be Z, right? So based on that X, Y, like based on the outcome, right, we'll try to see, okay, because of this reason X might be appeared, or based on this reason we got Y, and based on this we got Z. So these are called as an hypothesis, and we have to select a hypothesis which is very near to the target function which we don't know, right? So this is called as learning algorithm. Okay, so whatever training what we talk about in machine learning, right, is basically a learning algorithm which tries to find a hypothesis for the target, which nearly represents very near to the target functions. So when you do this target function, right, this hypothesis is tested on the new customers, whether my model is working or not. And informally, G is my model, right? Hypothesis set is nothing but the model that I do create. So G is nothing but your model. And the whole idea is we want to come up with a model which is very nearly exact as the function. That's the goal of learning, and which is also the goal of machine learning. Okay. So we know the only one thing that only information we have is the past data, historical data, right? D. And the good thing about it is that the function is fixed for all the data points, but unfortunately we don't know, right? So the whole idea is to determine the model and the learning algorithm. So if I take if I put it as a flowchart, then I want to understand the unknown target function from the training data, and hypothesis is nothing but my model, and I use a learning algorithm which is nothing but a training. Okay, you give the training data and the training algorithm would come up with a model G, which is a close representation of the function here. This is the intuition of machine learning, nothing else. This is the idea behind. So if you go and dissect the source code of Python frameworks like Skykit, they do the same thing. And here in this session, we'll just go into a simple model, how the learning algorithm works. Okay. So as I told you, it's an input vector, and we have a bytes, and we can compute the credit score. Basically, this is the probability, right? So I have an input vector, and then I take the product of the vector and the bytes. I get a score, and I have a threshold. Generally, it is like a CIBIL score. Let us take a CIBIL score as the one thing. If I get the total threshold, which is if my score is greater than the threshold, then I will approve the loan. Otherwise, I will reject the loan. Right? This is a simple learning model. The next question is, how can we write this hypothesis? The hypothesis, we can write it as a, if you see here, right? So the sign. So what is a sign? If I'm going to accept lend money, then it will be +1. If I'm rejecting, it will be -1, right? Based on the score, right? And then the bias, we will not go deeper into it. We'll go it later. We will go deeper into it later. And basic idea is you come up with a decision set, right? Whether I need to lend a loan or reject the loan application, right? So this hypothesis set is called as a perceptor or linear separator geometrically. So, for example, if I represent this as a geometry, see, at the end of the day, the magic of machine learning is in mathematics. So whenever someone comes up, ask what is happening with machine learning, how the magic happens, there is no magic. It's only mathematics. Mathematics, especially optimization and probability, right? These are the two ingredients that creates magic of machine learning. Okay, that's what rationally this is what we do, right? So basically what happens is that we want to create a separator which will tell whether I need to lend the money or reject the money. Okay. So these are my data points. I want to have the separator, and ideally this right side is the one thing that I want to have, right? Whatever, like let us say I have 10 data points, uh, say 9 data points, 4 of them have the rejection and 5 of them have acceptance. Then I want to come up with this kind of separator where I know that all the accepted would come here and the rejection would come other side, right? But unfortunately, it won't happen in the real scenario. Even if you try to do it, right, you cannot get 100% testing accuracy when you are doing the testing, right? Testing and training, you won't get it, right? It stops at some time, and most of the time it will stop at around 99%. And then we claim that it is accuracy. No. Whatever you are doing is fitting the data that you have seen. But unfortunately, your model is going to run on the unknown data. Okay. See, it's similar to the things, right? We are all teachers. We take classes. Our students will listen to us, will like they answer the question paper that what we have said, but unfortunately they won't be working under us, right? They go and work in the company, right? So basically what we are doing is a machine learning itself, right? So idealistically what happens is that we whatever the classes we take, what are the courses we teach, what are the projects we ask them to do, we train them or build a knowledge for them, basically a model inside them, so that when they go to the job, they pick it up and do the things very smoothly. But unfortunately, nowadays the students have more concerned about the reels rather than the real systems. So their model is too weak, even in academy, and then they with lot of with a lot of effort they try to update their model when they go for a job. So this is what typically happening. So let us try to understand, right? So these are the things, and when we do the misclassification, when I in the if you see when you train your model with chi fate or something, right? You will not train for one time interval. You repeat it multiple times. Why? Have you ever thought why we need to repeat it? So in the first time, what happens is that I come up with a weight that would misclassify, which might not include all the data points, right? So here in this case, one of the data point which is supposed to be in this side, on the other side, and what are the other two, the red cross, which is supposed to be on the lower side, is on the higher side, right? So what we have to do is we have to revisit and update the weight so that the linear separator would still try to reduce the misclassification. So how can we do that? We want to improve the weight vector. And how we do it, what happens is that we pick the misclassified example and update their weight, right? So in this way, every epoch, you try keep on updating the weights And after you train it for 10 epochs or 20 epochs, you will find that the accuracy is more or less like a stable, and we stop there. That's where we tell that the model has been created, right? So this is how the things work. So what are the other ways of learning? So as I told you, learning is not a first thing. Most of us, we borrow it from statistics, right? In statistics, what we do is we use a set of observations to uncover underlying process. In data mining, we try to find patterns, and we have different learning paradigms, right? In supervised, we tell the answer first, right? In reinforcement, we give feedback on the answer. For example, right, most of us have kids, right? Whenever they have the good behavior, we give them a chocolate, and whenever they have the bad behavior, we won't give them the chocolate, or we might scold them, right? That is a feedback that their brain will take it, saying that okay, what they have done is right, or what they have done is wrong. Okay, and then in unsupervised, we will learn to organize the data, right? So these are the different paradigms that with respect to the learning. And the question is, the target function is the object of learning. What if you go back, right? I want to understand how the f is the function has been created. Like what is my f? But unfortunately, it is unknown. And the thing is, whatever the data that I get, right, if it is labeled, if you take this first off, right, you have 6 squares, and each of them have a different